Okay, we're all set. All right, hey everybody, I'm Rick,
I'm Ashley.
and collectively we are known as
Rick
Ashley. Anyway, so today's webinar we'll be using our three instruments that we have. We have the Microvis, the VROC, and the VROC II. And so what we'll do is we will test samples using the minimum sample volume for each instrument. And we'll show you what kind of data you can get out of it. And so Ashley will go ahead and start with the Microvis.
So the Microvis minimum volume is 100 microliters. The pipettes hold about 400 microliters, and it is just a flow-through system. So it will just flow straight to waste. What's different of the Microvis compared to our other instruments is that you don't have to use the software. You can operate it just from the screen here. So I'm going to load roughly 100 microliters. As I said, these pipettes fit about 400, so about 1/4 the pipette. And so then we will load up the Microvis by clicking in the pipette. And then at this point, we'll just hit run. And so I'm running in auto mode, which is where it picks the best shear rate for you based on the viscosity and the chip you have chosen. As you can see, the Microvis is very easy to use. It's as simple as loading a pipette and clicking run. So for all the instruments today, we'll be testing isopropyl alcohol. It has a viscosity of roughly 2.2 at the room temperature of our office. So right now it's just moving the pusher block to the end of the pipette. So it is now engaged. So right now it's priming to pick the best shear rate to run the sample at. And now it will test your sample. So we got an R² value of 1, which is one of our control methods to make sure it's a good measurement. And we got a viscosity of 2.3, which is, again, what I would expect from 2.2 to 2.3 with this IPA and at this room temperature. So as you can see, that took a little bit more than 100 microliters, and that's because it had to prime on auto mode and then run it. The subsequent runs would take less than 100 microliters, but that always is something to keep in mind with Microvis. To say get 4 repeats, I'd probably need 300 to 400 microliters. And so if I only had 100, 150 microliters, I would get a data point, but I would not get multiple data points to be able to check repeatability. And so that's kind of where we move on to our next instrument, the VROC II. And so I will go ahead. So these, unlike the Microvis, are going to have a reusable syringe, where the Microvis, you might have noticed, has a disposable pipette. So with the VROC I, those of you familiar might know we use a union to load these. And then when Rick does the VROC II, you'll see that now we've switched to a positive displacement pipette where we backload. So we've switched the loading a bit, which is easier because you'll see here, I most likely will pull up a bubble and have to push it out. Sorry, I'm left-handed. This is making my camera operator's life harder. Where if I backfilled it, I wouldn't quite have to worry about the bubble. And so that is part of the reason we made that change. So I'm going to go ahead and push out this bubble. And so now my syringe is full with about 50 to 60 microliters. And something about the VROC, unlike the VROC II and the microvisc, is you are going to have to type in the amount of volume you have. Both our other instruments will automatically find the end of the syringe and let you know how much is in there. So sometimes it can be tricky to try to figure out the exact amount you have. So with the VROC I, you have to move the pusher block to the end of the syringe and then lock it. And then at this point, we open the flow valve and we close this. This is for temperature control, but since temperature control is not built in for the VROC I, you have a separate unit. We did not bring that in. So at this point, I am going to share my screen so you guys can hopefully see the software. All right, so as you can see, this software has some basic things you need to enter in order to get the run parameters. So the first thing you need to enter is your measurement or sample ID. So for this, it's IPA, your estimated viscosity. So I'm going to say 2.2. But if I didn't know anything about my sample, this could be tricky. Again, with our other instruments, the VROC II and the microvisc, you're not going to need an estimated viscosity, so it's much easier when you haven't used a sample before. But for the VROC I, you can look at your sample and try to estimate the best estimated viscosity and change it from there. And then, as I mentioned, you have to put in your sample volume. All right, so this measurement is going to be set up to take about 50 microliters. And so if I don't think the pusher block is engaged, I can click this, but it is. So I'm going to go ahead and hit start. And when we pull up the VROC II software, you will see we've changed a lot of adjustments about the software and the way it looks and the way it functions. But as you can see, that was very easy to do. A few things I had to type in, click start, and I already have a viscosity measurement in less than a minute. So as you can see here, I got a apparent viscosity of 2.25, and I ran it at a shear rate of about 7,480 inverse seconds. So, and I got an R squared of 1, just like on the microvisc. So at this point, I'm gonna pass this on to Rick, who's going to show the VROC II, and then we can see the difference between the three instruments.
Hey everybody, so as Ashley mentioned, the VROC II has basic differences to the original VROC, and one of them is it's a much more automated system, where with the VROC I, you had to know a little bit about your sample. For example, you had to know an estimated viscosity, you had to know the sample volume you loaded, but with the VROC II, all of that has been automated. And so what I'll do is I will do a 15 microliter sample volume test. And a nice thing about the VROC II is the ability to do unlimited testing with the same volume. So as you saw with the VROC I and microvisc, the one volume you get one measurement, whereas with the VROC II, the same volume you can do unlimited measurements, and that includes shear rate sweeps and temperature sweeps, along with the ability to recover the sample. And so some of our clients like to see, is there impact of shear on their molecule? Can their molecule withstand high shear rates seen in injectability, manufacturing, filtration? And so you don't have to devote a lot of sample volume to actually start to see those types of, to do those type of tests to see if there's any type of impact on the structure of your sample. And so the first thing I'll do is put on my gloves. And I will load 15 microliters of IPA into the 100 microliter syringe. And we use positive displacement pipettes because 15 microliters is such a small amount. We have to make sure that we get every microliter that we can. And with every purchase, a positive displacement comes with the VROC II. So how we load is we do a backloading technique where we remove the plunger from the barrel. And then I pull up 15 microliters. So 15 microliters is a very small amount. It's basically just the tip of the pipette. And now we load it into the back of the syringe. And we carefully put the plunger in. And so now you can see the 15 microliters. And what we do is we develop this technique where we actually don't push the entire contents all the way up because this hub is actually greater than 15 microliters, so your sample will actually disappear. So we developed a technique where you push the air bubble to the tip of the 30 microliter mark. And so from here, we can do our test. So some of the upgrades that we have with the VROC II is we've actually made the chip smaller. And so now we can do this type of testing with such small volumes because there's very little dead space now. So the first thing I do is I attach the syringe to the chip, and then I attach what we call a reservoir. And this reservoir is pressurized so that now we can do unlimited testing by retrieving the sample, pressurizing the reservoir, and that will push the sample back into the syringe. And then we test, and then we can retrieve, test, retrieve, and we can do this an unlimited number of times with the same volume. So now I'll go ahead and put it into our VROC II, turn on the instrument. It's a very simple process of connecting this tube, which pressurizes the reservoir. Put it into this cradle. You notice that this was originally purple. It's turned green. That tells me that the connection with the chip and the software has been established. Close the top, and now basically I go into the software to run my experiment. Another cool thing is that we have this barcode reader. And so if you have barcoded your samples, you just use the barcode reader to read the sample, and that will take the information and name your sample.
Let me share my screen first.
Okay. So this is the software that powers the VROC II. And for those Initium users that we have, you'll notice that it does look similar. And the Initium is our fully automated system where only 19 microliters is needed for limited testing, and you have the ability to choose either a 40 valve rack or 96 well plate to match well with your liquid handlers. And so what we learned with our fully automatic Initial 1 Plus system, we've taken that and kind of shrunk it down to the VROC II. And so this is an example of what the software looks like. And so this particular program that we have running includes a priming step and then 10 repeats of the same sample. And so once you've loaded it into the VROC II, you basically hit, you name your sample, and this is where the barcode is nice. So this is IPA. And then this is the protocol that I will be using. It's automatic 10 repeats, very simple. The nice thing too about our technology is that you have the flexibility to create customized protocols. So if you have a protocol or a testing measurement that you want to do all the time, you've got it at your fingertips, basically. Now I just hit start, and then the automatic functionality of the VROC II will take over. So one of the things that we also think about is, this is a tutorial. We also have within the software tutorial so that it reminds you of certain basic testing procedures. And so you can just hit next. Goes over also how you should load, or how you should attach the syringe to the chip. So it's a lot of useful functionalities that we've included. So one of the things that we also do is we make sure that the testing parameters or environment are optimized. And so what we have is what we call a pre-diagnostic run. And so that will check the health of the chip as well as look for leaks that could be in the system. So we'll see that now.
So just like the microbit, the pressure block needs to find the end of the syringe, unlike MD where you have to.
Yeah, so once the pusher block comes in contact with the end of the syringe, then it gives us instructions, like for example, close the latch to secure the syringe. And this is the pre-diagnostic run that I was talking about. And so with such small sample volumes, you want to make sure that you're running under optimal conditions because there's such small room for error. And so this will go through the system itself to make sure everything is working as it should, so that your data is very accurate and with very high repeatability. So right now the MEMS chip test has passed. That looks at the pressure sensors inside of the chip to make sure they're functioning properly. We also did a reservoir chip leak test. And so once those pass, it goes on to the next step of actually doing the measurement. And so here I loaded, after the first measurement, we'll get a loaded volume. And so what the instrument is doing now, it's investigating what the viscosity is at certain shear rates.
Mm-hmm. But it's still pushing out that air deloaded as a gap between the sample. Mm-hmm. So that's why you see the graphs looking like this.
Right. And so once the sample hits the first pressure sensor, then we begin the initial testing. So that was just the priming phase. Here we go, it's looking at the sample now. So I loaded 14.7 microliters. And basically all you do now is wait for the data. Everything else is automated. So it's a really great system to do a measurement without having a lot of hands-on time. And we've also removed human error components of the testing. So if there are multiple end users, with some systems, you have to be very good at loading consistently to get consistent results. But with our technology, you basically just load a syringe and our software takes care of the rest. So right now you're seeing different graphs within the same page, viscosity versus time. You see the pressure versus sensor position, and that's R squared values. On the top right is temperature over time. I did not set the temperature, so we're just operating in ambient conditions. And then the lower right is viscosity versus which segment you're running or how many repeats you're doing. You also have the ability, like I said earlier, to do different types of sweep functions. For example, if I wanted to, I could have done a temperature sweep from 4C all the way up to 70C. You could also do shear rate sweeps, going from minimum shear rates to maximum shear rates that the chip can handle. Typically, we do use a little bit more than 15 microliters for shear rate sweeps, but for basic testing, and if you're really limited on viscosity or sample volume, you can begin to gain or obtain relevant data with only 15 microliters.
You can also see the data in table format, just like how I showed on VROC I. But as you can see, we've already collected more data points than we ever could with 50 microliters on the VROC I, and we only used 15 on the VROC II.
Yes.
So we're about halfway through the measurement since it's doing 10 repeats plus that timing. Does anyone have any questions we could answer while this finishes the test?
While we're waiting for some questions, the VROC II, like our initial automatic viscometer, not only does retrieval so that you could do unlimited testing, but it also recovers the sample automatically. And with the VROC II, it recovers it back into the syringe. And with the Initium 1 Plus automatic viscometer, you can actually recover it back into the same vial or well plate, or designate it to be saved in a different well plate or vial. We can go back to the table to see what the data looks like. And it's very, very consistent. The very first measurement was 2.25, the second one was 2.244, 2.248, 2.25, 2.252, 2.248. So it's extremely precise. You don't have to worry about lack of repeatability even with such small sample volumes.
One thing you may notice is that it's wet. That means the chip is dirty up at the top where Rick is hovering his mouse. And so that means that when I'm done, that's a nice warning. If I had someone else use this chip and they just put it away instead of cleaning it, when I put it in the instrument, it would say wet and I would know it's not clean and dry. And so what we would do after this measurement is put it on our chip cleaning station, which is automated. We would set the cleaning, and then at the end, it would ensure that the chip is clean as well as dried completely. And then when we would place the chip back on the instrument, it would say dry.
Right, I think we're almost done with this experiment. This is number 9 that's going through, and we'll just have one more. So some of the information that I like to look at, obviously, is the viscosity, see how the repeatability is. We operated at a shear rate of 2,165. R squared values of 1 and 0.9999, so I know the flow is laminar. Yeah, so it's doing an experiment with such small sample volume is as easy as picking a protocol and then hitting start. Yeah. Okay, we are done with our experiment. We got one more actually. And so this is actually recovering back into the syringe.
Mm-hmm. Yeah, the system will actually recover most of your sample after it is done testing, just in case you want to do additional testing later on with the sample. You don't even lose that whole 15 microliters.
Right. Yeah, some of our clients that have adapted to the VROC II find that recovery is very helpful, particularly when looking at stability. You could do a lot of this work early on that maybe was pushed off later downstream because of volume restrictions. But now we're finding that doing this much earlier on can streamline your process and even possibly get your drug out to market faster, saving you a lot of time, energy, and money. Okay, so that's it. Our testing is complete. And as the tutorial says or shows us, this is how you remove your chip from the VROC II.
And so Rick will flip up the latch, or what we sometimes call the guillotine, and then you can use this home button, just like the microwave, to unengage the plunger.
So that was it. Doing experiments are as simple as that. As we showed, we have different instruments to match your particular application and testing requirements. I think the VROC II is kind of the best of both worlds, where you have the ability to test very small sample volume while also having the ability to recover your sample. And with automation, the hard work has been taken away. It's basically just loading a syringe, picking your protocol, and hitting run to get your data. Okay, so we're happy to take any questions now. Okay, we have some questions coming in. So what is the shear rate range? So the overall shear rate range of the VROC II is, I believe it's as low as about 5 inverse seconds, but we can reach a maximum of 2.02 million inverse seconds with a regular speed pump, and near 5 million inverse seconds for the double speed pump or 2x pump. Okay, another question is, you're successfully able to do an experiment with less than 15 microliters, 14.7.
And then the rest of it says, does it work with less than 15 microliters?
So it can. We pick 15 because we try to be as conservative as possible with our loading volumes. And so it is possible to go less than 15. I believe 13 is about as low as we have gone. So you can go below 15, but 15 is a good safety for you. So, shear rate range, I think we got that.
I think we have gone through the questions.
I thought there was a question about shear rate sweeps.
Yes.
So a shear rate sweep is actually very simple to do. Maybe we could, let's share our screen to show what we call level generator. And that is a nice and easy way to show or to do a shear rate sweep. And level generator, again, it's a fully automated way to do shear rate sweeps without having to pick shear rates. Or if you want to pick shear rates, you could do that too. So level generator is our way of saying, you know, how can you do a shear rate sweep? You don't know that much about your sample. And so how level generator works is we choose, let me get out of the tutorial. And so level generator works by using pressure. And so since our system is based off of pressure drop, we use high pressure drop and low pressure drop to set the boundaries for our shear rate sweep. And so 5% is the low end, and 95% is the high end of the pressure scale. And so when we put those in, levels is how many individual shear rates you want to test at. So let's say we want 5. And then show levels. And these would be the levels that we will be testing at. Okay. And then if you want to do a temperature, you could add temperature here. Let's say 25. And how many repeats means how many repeats at each individual level. And so we usually do 5. So that way we're assured of the repeatability. And then the order is ascending or descending. And all this means is ascending means going from low percent to high percent, and descending is going from high percent to low percent. So now we've got this. And so I hit append, and that adds on to a template that I was in. And so here we could see the first 3 are the system is investigating what does the sample look like. And this is important because if your sample is Newtonian, then the viscosity won't change as a function of shear rate. But if it's non-Newtonian, then we know viscosity will change as a function of shear rate. And so this is investigating whether or not is this sample Newtonian or non-Newtonian. And it takes that into account when it does the 5%, 27.5%, 50%, 75, and 95%, what we call full scale. And so this is how you would do a shear rate sweep. And so it's a very simple procedure. Our software goes through step by step on how to do it. So it doesn't take a lot of time to master our technology and to master our software.
All right, Rick, we have 2 more questions.
Okay.
One question is, how do you export the data format for VROC II?
You can export that through either in PDF or CSV or Excel. Our system is also, or the VROC II and Initium 1 Plus is 21 CFR Part 11 compliant, and so it is database. It has a database which will save all of your data and is it cannot be manipulated. So if you are in a GMP environment, for example, it works very well in that type of strict testing.
I think our second question was just if it's 21 CFR compliant.
It is.
So you answered that on your first question.
Yeah, so the VROC I and the MicroVis are not 21 CFR compliant, whereas the VROC II and our Initium 1 Plus automatic viscometer are.
All right, well, I think we answered all the questions, but if we missed anyone's questions, we will reach out to you afterwards. And if there are any questions you didn't think of right now, but come to mind later on, feel free to email us and we will go ahead and answer your question.
Great. Thanks, everybody. Thanks for joining.
Thanks, everyone.